Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about cross correlation function of the random process x of t and y of t. Now here in this video, we are going to discuss about properties of cross correlation function. Let us study some of the important properties of the cross correlation function of two random process x of t and y of t, which are jointly wide sense stationary random process. And the first property is the cross correlation function is not generally an even function of tau. So that is Rxy of tau is equal to Ryx of minus tau is a symmetry property. And the proof of this property is the cross correlation function of the random process x of t and y of t is given by Rxy of tau is equal expectation of x of t into y of t plus tau. In this equation, tau is replaced by minus tau. Okay. Similarly, the cross correlation function of the random process y of t and x of t definition is Ryx of tau is equal expectation of y of t x of t plus tau. So in this equation, in this second definition, tau is replaced by minus tau. We get Ryx of minus tau is equal expectation of y of t into x of t minus tau. Let t minus tau is equal to a or u, t minus tau is equal to u. So t is equal to u plus tau. Substitute t is equal to u plus tau, t minus tau is equal to u into RHS term of this equation. We get Ryx of minus tau is equal expectation of y of t. T is u plus tau, x of t minus tau is u. So u of t plus tau x of u is also rearranged as expectation of x of u into y of u plus tau. From the definition of cross correlation function of the random process, expectation of x of t, y of t plus tau is Rxy of tau. So using this definition, the RHS term of this equation is cross correlation function of the random process x of t and y of t. So that is Rxy of tau. So therefore, Ryx of minus tau is equal Rxy of tau. So which is a symmetry property. And second property, if two random process x of t and y of t and Rxy of tau and Rxx of tau, Ryy of tau are the autocorrelation function of the random process x of t and y of t and their respective autocorrelation functions, then the relation magnitude of Rxy of tau less than or equal to square root of Rxx of 0 into Ryy of 0. Now here there are two random process x of t and y of t. So the autocorrelation function of the random process x of t is Rxx of tau. Autocorrelation function of the random process y of t is Ryy of tau. Rxy of tau is the cross correlation function of the random process x of t and y of t. Now coming to the proof, consider expectation of x of t divided by square root of Rxx of 0 plus or minus y of t square root of Ryy of 0 whole square is greater than or equal to 0. So now here this within the bracket term applying a plus or minus b whole square expansion, that is a square plus b square plus or minus 2ab. So first applying expansion of a plus or minus b whole square within the bracket term. Expectation of x square of t square root of Rxx of 0 whole square. Square and under root is cancelled, that is Rxx of 0 plus y square of t divided by Ryy of 0. Here also square and root is cancelled, plus or minus 2 x of t y of t divided by square root of Rxx of 0 into square root of Ryy of 0 is greater than or equal to 0. So using expectation property, expectation of sum of random variables is equal to sum of their individual expectation. So using that property, the LHS term of this equation is expectation of x square of t divided by Rxx of 0 plus expectation of y square of t divided by Ryy of 0 plus or minus 2
expectation of x of t y of t divided by square root of rxx of 0 into ryy of 0 is greater than or equal to 0. From the one of the property of the autocorrelation function, the mean square value of the random process is rxx of 0. So that is expectation of x square of t is rxx of 0. Expectation of y square of t is ryy of 0. So this is one of the property of autocorrelation function of the random process x of t and y of t. And applying this property into above equation, we get, so numerator term is, first numerator term is rxx of 0 plus second numerator term is ryy of 0 plus, and third term numerator term is expectation of x of t into y of t is the cross correlation function of the random process x of t and y of t definition, that is rxy of tau. So now here numerator and denominator, first term and second term, rxx of 0, ryy of 0 is the cancel. The remaining term is 1 plus 1 is 2. So this term is going to the RHS side. We have now here plus or minus is there. Going to the RHS side, we have minus or plus. So 2 greater than or equal to minus or plus 2 rxy of tau divided by square root of rxx of 0 ryy of 0. On both sides 2 is the cancel. We have square root of rxx of 0 into ryy of 0 is greater than or equal to minus or plus rxy of tau. So this minus or plus means that is magnitude. So this minus or plus is written as magnitude of rxy of tau is less than or equal to square root of rxx of 0 ryy of 0. So this is second property of cross correlation function. And third property is, if x of t and y of t are two random process and their autocorrelation functions are rxx of tau and ryy of tau, are their respective autocorrelation functions, then the relation determinant of rxy of tau is less than or equal to 1 by 2 rxx of 0 plus ryy of 0. Now coming to the proof. So we know that the inequality the statement of the inequality, that the geometric mean of two positive quantities is less than their arithmetic mean. Once again, the statement of the inequality, the geometric mean of two positive quantities is less than their arithmetic mean. That is square root of rxx of 0 into ryy of 0 is less than or equal to rxx of 0 plus ryy of 0 by 2. So using above property means second property of cross correlation function of the random process, that is determinant of rxy of tau is less than or equal to square root of rxx of 0 ryy of 0. Okay, applying this property into above expression, we arrive at determinant of rxy of tau is less than or equal to, okay, so this is less than or equal greater less than or equal to rxx of 0 plus ryy of 0 by 2. This is the third property. And next property, if the random process x of t and y of t are independent to each other, then their cross correlation function satisfy the relation rxy of tau is equal ryx of tau is equal expectation of x of t into expectation of y of t. So we know that from the definition of cross correlation function of the random process x of t and y of t is rxy of tau is equal expectation of x of t into y of t plus tau. Now here the random process x of t and y of t are the independent random process. So the condition of expectation of x of t, y of t plus tau is expectation of x of t into expectation of y of t plus tau. Since the random process y of t is stationary random process, then expectation of y of t plus tau is expectation of y of t. So using the stationary random process condition from this equation, r x y of tau is equal expectation of x of t into expectation of y of t. So similarly prove that r y x of tau is equal expectation of x of t, expectation of y of t in the same process. In similar manner, we can prove that uh, r y x of tau is equal expectation of x of t into expectation of y of t. Next property, if two random process x of t and y of t have zero mean and are jointly wide sense stationary, then limit tau tends to infinity r x y of tau is equal to 0. So from the above property, the mean of the random process is not equal to 0. So mean of the random process is not equal to 0. What is that statement? R x y of tau is equal to expectation of x of t, expectation of y of t. So now here in this property, the mean of the random process are 0. That is expectation of x of t is equal to 0 and expectation of y of t is equal to 0. Applying that mean of the random process is equal to 0 condition into above property, we get limit tau tends to infinity r x y of tau is equal to 0. So we know that this is the definition of the cross correlation function of the random process. So taking limit tau tends to infinity on both sides, we get limit tau tends to infinity r x y of tau is equal limit tau tends to infinity expectation of x of t y of t plus tau. As tau tends to infinity, the random process x of t and y of t can be considered as a independent random process. So that is, the RHS term of this equation is written as limit tau tends to infinity expectation of x of t into expectation of y of t plus tau. Since y of t is a stationary random process, then expectation of y of t plus tau is equal expectation of y of t. Applying this condition into above equation, therefore, limit tau tends to infinity r x y of tau is equal limit tau tends to infinity expectation of x of t into expectation of y of t. So now here the mean of the random process are 0. So therefore, applying that mean of the random process is equal to 0 into this equation, we get limit tau tends to infinity r x y of tau is equal to 0. Similarly, you can prove that limit tau tends to infinity r y x of tau is equal to 0. The next property, if the random process x of t and y of t have periodic component with a period capital T naught, then their cross correlation functions r x y of tau and r y x of tau will also contain the same periodic component with the same period T naught. Next property, two random process x of t and y of t are said to be uncorrelated, and if their cross correlation function is equal to the product of their means. So that is r x y of t is equal expectation of x of t into expectation of y of t. So these are some important properties of cross correlation function of the random process x of t and y of t.